They told her her mind was too fragile, too delicate for the rigors of science. A woman's place, they whispered, was far from the cold, hard facts of the universe. But Annie wouldn't accept their pronouncements. She refused to be confined by the narrow views of a world that sought to limit her potential based solely on her gender. Her spirit, however, was as boundless as the night sky she longed to explore. She knew, deep within, that her intellect was capable of far more than society deemed acceptable, and the cosmos itself seemed to beckon her call. Born in Delaware in 1863, Annie absorbed the wonders of the night sky from her mother, Mary Jump, who instilled in her a profound love for celestial observation. Even as a child, she possessed an insatiable curiosity, a hunger for understanding the vastness above, the silent, glittering expanse that stretched beyond human comprehension. Her mother's teachings were the first sparks igniting a lifelong passion for the cosmos, a passion that would eventually lead her to chart the very stars they admired. She dreamed of formal training, of delving into the scientific mysteries that beckoned from the heavens, of engaging with the great minds of her era. But the doors of higher education, especially in science, were largely closed to women. The scientific community of the late 19th century, steeped in tradition, saw no place for her intellect, no room for a female voice in its hallowed halls. This was a significant barrier, a societal wall built of prejudice and custom, one that threatened to extinguish her burning ambition before it could truly ignite. Undeterred by these barriers, Annie channeled her passion into an unlikely pursuit, photography. She learned to capture images of the sky, an early foray into scientific imaging that allowed her to record the light of distant worlds. It was a practical, hands-on way to engage, to gather data, to begin her own astronomical catalog, even without access to a university lecture hall or laboratory. This self-education was crucial, a testament to her unwavering commitment to understanding the universe, one captured photon at a time. Then came a pivotal opportunity, a chance to work at the prestigious Harvard College Observatory in 1894. Not as a recognized scientist, but as a computer, one of the many women hired to perform the painstaking calculations and data reduction that male astronomers, burdened by other tasks, often deemed too tedious or time-consuming. These women were the unsung workforce behind many astronomical discoveries of the era, the silent engines driving scientific progress, their contributions often overlooked in the annals of history. It was here, in a cramped attic room on the third floor of the observatory, filled with the scent of dust and chemicals, that Annie Jump Cannon truly found her life's work. Surrounded by unfinished projects, piles of spectral data from countless distant suns, and the quiet hum of scientific inquiry, she began her monumental task of bringing order to the chaos of the stars. This humble space became her universe, her sanctuary of discovery, where she would dedicate herself to unraveling the secrets held within starlight. Her work was relentless, consuming. Day after day, Annie pored over hundreds of thousands of photographic plates, each one a snapshot of light from across unimaginable distances. She scrutinized the faint, intricate lines of starlight, the spectral signatures. Each line, each shade, was a vital clue to a star's temperature, its chemical composition, its very essence and place in the universe. This was not mere data entry, it was a profound act of deciphering the cosmic language whispered from the void, a language only she seemed able to truly understand. The observatory's director, Edward Pickering, a man of vision, recognized her extraordinary talent and unwavering dedication. He granted her the unprecedented freedom to classify stars according to their spectral types, a trust that would prove foundational to stellar astronomy. He believed in her unique ability to impose order on the celestial panorama, a trust that would redefine our understanding of the cosmos and its inhabitants, seeing in her the potential that others had dismissed due to her sex. She developed an ingenious, elegant system, a classification of stars based primarily on their surface temperature, using letters. A system so intuitive, so comprehensive, it would become the bedrock of stellar astronomy for generations to come. The letters themselves, O, B, A, F, G, K, M, became a universal language, a fundamental tool for understanding the stellar populations of our galaxy and beyond, a testament to her ability to find order in apparent chaos. The O stars, the hottest of the classification, burned with a fierce, almost violent blue-white light, their surfaces searing at temperatures exceeding 30,000 Kelvin. The B stars, still incredibly hot, radiated a brilliant white light, their temperatures ranging from 10,000 to 30,000 Kelvin. The A stars shimmered with a vibrant white light, typically between 7,500 and 10,000 Kelvin. Each spectral type a distinct signature, a unique fingerprint etched in light across the vastness of space. Then came the F stars, with a distinct yellowish-white glow, their temperatures hovering around 6,000 to 7,500 Kelvin. The G stars, like our own Sun, blazed with a warm yellow light, typically between 5,200 and 6,000 Kelvin. The K stars offered a mellow orange hue, with surface temperatures from 3,700 to 5,200 Kelvin, and finally, the M stars, the most common type, glowed a deep red, cooler still, ranging from 2,400 to 3,700 Kelvin. Annie's system was elegant in its simplicity and profound in its implications. It provided a unified framework, a common language for astronomers worldwide. By analyzing the light from any star, scientists could now determine its spectral type, and from that, deduce crucial information about its physical properties. This classification was not just an organizational tool, it was a key that unlocked a deeper understanding of stellar evolution, cosmic distances, and the very nature of the universe. Her dedication was extraordinary. Over her career, she examined an estimated 350,000 stellar spectra, meticulously classifying each one by hand. She worked tirelessly, often from dawn until dusk, her eyes trained on the subtle nuances of light, her hands steady as she recorded her findings. This was a feat of endurance as much as intellect, a marathon of cosmic observation that few could even contemplate. She developed a remarkable visual acuity, her eyes becoming finely tuned instruments. She could discern minute differences in spectral lines that others missed, identifying subtle variations in temperature and chemical composition. This honed ability, combined with her systematic approach, allowed her to achieve an unprecedented level of accuracy and consistency in her classifications. Her sight became a gateway to the stars. She became known as the woman who classifies the stars. Her name was synonymous with the very fabric of the cosmos. Yet, despite her monumental achievements, Annie Jump Cannon was not granted a formal professorship at Harvard until much later in her career. The systemic barriers for women in academia persisted, a stark reminder of the battles still to be fought. Her work had profound implications for understanding the universe. By classifying stars, Annie was effectively charting the life cycles of stars. She realized that stars changed over time, evolving from hot, blue giants to cooler, red dwarfs, following predictable paths dictated by physics and chemistry. Her catalog was a living census of stellar evolution, a snapshot of the cosmos in motion. The Observatory sequence, her crowning achievement, became the standard for astronomers worldwide. It was adopted by observatories and researchers everywhere, from the largest institutions to the smallest university departments. It was the language of the stars, spoken fluently by scientists across the globe, a common ground built by Annie's singular vision and tireless effort. Pickering recognized her immense contribution, awarding her the first Annie Jump Cannon Award in Astronomy in 1934, funded by the American Astronomical Society. This award, named in her honor, was to be given annually to an astronomer who had made outstanding contributions to the field, a lasting tribute to her legacy and a beacon for future generations of women in science. Her ability to see patterns where others saw only random points of light was a gift. It was akin to a musician hearing a symphony in individual notes, or a poet finding meaning in scattered words. Annie heard the silent music of the spheres, translating their complex harmonies into a comprehensible order that forever changed our perception of the universe. In 1925, she was finally recognized with an honorary degree from Oriel College, Oxford, a rare honor for a woman at that time. Though the path was arduous, her perseverance had broken through barriers, paving the way for countless women who would follow in her astronomical footsteps, proving that intellectual curiosity and scientific rigor knew no gender. She was a pioneer, a quiet revolutionary. In an era when women were largely excluded from scientific pursuits, Annie Jumpcannon, through sheer force of intellect and an unwavering commitment to her work, carved out a monumental space for herself in the annals of astronomy. Her contributions were not merely significant, they were foundational, shaping our understanding of the cosmos in ways that still resonate today, a testament to the power of a determined mind against prevailing prejudice. Her classification system, observatory, isn't just a mnemonic device, it's a profound statement about the physical properties of stars. It reveals that stars are not static entities but dynamic beings, evolving through distinct phases. The sequence reflects a deep physical reality, a cosmic order that Annie painstakingly uncovered. It's a testament to the power of observation and the human capacity to find patterns in the universe's grand design, a true echo of the scientific method in action. The very stars that had captivated her as a child in Delaware became her life's work, her profound connection to the universe. Each spectral plate was a conversation, a silent dialogue between her and the distant stellar furnaces. She didn't just observe them, she understood them, deciphering their temperatures, their compositions, their very life stories written in the language of light. This intimate understanding transcended mere scientific inquiry. Her legacy extends far beyond Harvard's walls. The observatory system is still the primary method for classifying stars today. Every time an astronomer points a telescope at a new celestial object and analyzes its spectrum, they are, in essence, using Annie Jumpcannon's eyes. Her meticulous work forms the bedrock of modern astrophysics, a silent, ever-present influence on our ongoing quest to understand our place in the cosmos. In 1931, she published her groundbreaking A Catalogue of the Spectra of 89,000 Stars Photographed with the Objective Spectrograph, a monumental work that solidified her position as a leading figure in astronomy. This massive compilation represented years of intense labor and unparalleled scientific insight, a definitive testament to her dedication and her unparalleled ability to bring order to the vastness of the universe, a true cornerstone of stellar cataloging. Annie Jumpcannon's life is a powerful testament to human resilience and the pursuit of knowledge against formidable odds. She defied societal expectations, broke through gender barriers, and dedicated her life to unraveling the mysteries of the universe. Her story reminds us that passion, perseverance, and a sharp intellect can illuminate even the darkest corners of the unknown, and can fundamentally change how we see our world. Her classification system, observatory, is more than just a series of letters, it's a scientific language that allows us to speak with the stars, to understand their temperatures, their compositions, and their evolutionary paths. This elegant system, born from countless hours of meticulous observation in a cramped attic, has become an indispensable tool for astronomers worldwide, a direct result of Annie's genius and her unwavering dedication to the stars above. The stars themselves, in their silent, brilliant dance, held the secret she sought. Annie Jumpcannon, through her extraordinary work, gave humanity a way to read those secrets, to understand the cosmic ballet unfolding across light years. Her classification system, a masterpiece of scientific insight, continues to guide our exploration of the universe, a constant echo of her profound connection to the celestial realm and its infinite wonders. Her ability to discern the subtle differences in the spectral lines of stars was unparalleled. It was a skill honed over years of dedicated work, a testament to her sharp intellect and her deep understanding of physics and chemistry. This visual acuity allowed her to identify even the faintest spectral signatures, distinguishing between stars that appeared identical to the untrained eye. This was her unique gift to astronomy. Annie Jumpcannon's journey is a profound reminder that true brilliance often shines brightest when challenged. Denied formal education, she forged her own path, her dedication to the stars unwavering. She didn't just classify stars, she unlocked their stories, making them accessible to us all. Her legacy is written in the heavens, a permanent fixture in our understanding of the universe. The scientific community eventually recognized her immense contributions, awarding her numerous honors, including an honorary doctorate from various institutions. Her system became the universal standard, a testament to the enduring power of her intellect and her groundbreaking work. She proved that a woman's mind was not fragile, but a powerful force capable of shaping scientific understanding for centuries to come, a true inspiration. Her story is a powerful inspiration, a beacon for anyone who has ever felt limited by circumstance or societal expectation. Annie Jump Cannon's life demonstrates that with passion, dedication, and an unwavering pursuit of knowledge, even the most formidable barriers can be overcome. She looked up at the stars and, instead of seeing an insurmountable void, saw a universe waiting to be understood, and she made that understanding possible for all of us. The stars she catalogued continue to burn, to evolve, to tell their ancient stories across the vastness of space. Her work, etched in the observatory sequence, remains the foundation of our understanding, a timeless testament to a mind that dared to explore the cosmos, and in doing so, changed how humanity perceives its place within it. Her legacy lives on, written in starlight. Her name deserves to travel further. A like and a subscribe are why Annie's meticulous work classifying the stars will be seen by more people.